The constellation of Centaurus holds an ancient legend of the immortal sage Chiron, who sacrificed himself to save Prometheus. Right here shines Alpha Centauri, the closest star system to us, hiding potentially habitable planets. Within these same boundaries lurks the Boomerang Nebula, the coldest place in the entire known universe. And the giant cluster Omega Centauri turned out to be the core of an ancient galaxy consumed by our Milky Way.
All right, let's get started. Today, we're heading to the southern skies, to a constellation that's, well, it's so much more than just a simple pattern of stars. We're going to be exploring Centaurus. Think of it as this incredible natural laboratory for astrophysics just hanging up there in the night sky.
You know, someone once called it an astronomical supermarket, and honestly, that's a perfect way to put it. Everything you could possibly want to study is right there. I mean, you've got our closest stellar neighbors, you've got the leftover bits of galaxies that got eaten, and you even have the coldest spot in the entire known universe. It's like a little slice of everything the cosmos has to offer, all packed into one place.
So here's how we're going to break this down. First, we'll look at the constellation's basic profile, how big it is and where you can see it. Then we'll zoom in on the star of the show, Alpha Centauri. After that, we'll explore some of the record-breaking objects hiding in deep space there. We'll even touch on the mythology behind it all, the story of Chiron, and we'll wrap up with some tips for all you observers out there. All right, first things first, let's talk about the basics. Just how big is Centaurus and where is it? Because before we can really appreciate all the amazing things inside it, we need to get a handle on the sheer amount of cosmic real estate it takes up. So 1060 square degrees, that's a big number, but what does it actually mean? It's tough to picture. Well, think about the full moon. Now imagine trying to tile this patch of sky with over 5,000 full moons. That's the kind of space we're talking about here. It's because it's so vast that it can hold such an incredible collection of objects, sprawling right across a really bright part of the Milky Way. So who gets to see this thing? Well, if you're anywhere south of 26 degrees north latitude, you're in luck. The whole constellation will be visible to you at some point during the year. That means everyone in the southern hemisphere gets a front row seat, but also folks in places like parts of India or North Africa. Now, if you're a bit further north, say between 26 and 52 degrees, things get tricky. You'll only get a partial view. The further north you go, the lower it sits on the horizon, and you start losing the southernmost stars. And for anyone north of that 52-degree line, I'm afraid you're out of luck. Centaurus won't rise for you at all.
And this leads to a really cool idea in astronomy, being circumpolar. What does that mean? It means some stars never set. For anyone living south of 30 degrees south, think Sydney or Santiago, the two brightest stars of Centaurus, Alpha and Beta, are always in the sky. Night after night, they just circle around the south celestial pole, like constant reliable beacons. Okay, so we've got the big picture. Now let's zoom in on the most famous star in the neighborhood, the Alpha Centauri system. Why is it so important? It really comes down to one simple, massive fact. It is the closest star system to us. So here's the thing about Alpha Centauri. It's not just one star. It's actually a party of three, all gravitationally tied together. You've got the main duo, Alpha Centauri A and B. They're both pretty much like our sun, and they're locked in this beautiful 80-year orbital dance. Then you have this third, much smaller and more distant companion, a little red dwarf named Proxima Centauri, which circles the main pair. And that first star, Alpha Centauri A, is just, well, it's astonishingly similar to our own sun. They're both what we call G2V stars. What that means in plain English is they're practically twins in terms of size, temperature, and even color. It's like having a copy of our own star right next door, which gives us this incredible chance to study how stars like ours work. And the discoveries just keep coming. I mean, we've known about the two bright stars for centuries, but tiny little Proxima wasn't even spotted until 1915. And it's a feisty one, a flare star that can have these massive, violent eruptions. Then, in 2016, everything changed. We found a planet, Proxima b, orbiting that very star, our closest stellar neighbor. That discovery just completely supercharged the search for life out there. All right, let's pull our view back out now. Beyond our immediate neighbors, Centaurus is hiding some serious heavy hitters in deep space. We're talking about cosmic record breakers, objects that are truly pushing the boundaries of what we thought was possible. First up is Omega Centauri. Trying to wrap your head around this thing is difficult. It's a globular cluster, the biggest and brightest one we can see from the Milky Way, and it's packed with something like 10 million stars. But here's the twist. Modern science tells us it's not really a cluster at all. It's the leftover, super dense core of a small galaxy that our own Milky Way literally ate billions of years ago. We're looking at a galactic ghost. Next, we have Centaurus A. This is a truly weird-looking galaxy, and for good reason, it's the scene of a cosmic car crash. A huge elliptical galaxy and a spiral galaxy smashed into each other. The most incredible part, though, are these two enormous jets of particles shooting out from its center. And the engine driving all that? A supermassive black hole that's 55 million times the mass of our sun. Just staggering. But maybe the craziest record of all belongs to the Boomerang Nebula. Get this. At 1 degree Kelvin, that's just 1 degree above absolute zero, it is the coldest natural place we have ever found, anywhere, in the entire universe. It's even colder than the background radiation left over from the Big Bang. Think about that for a second. So how on earth does it get that cold? Well, it's a process called adiabatic cooling. Basically, gas is blasting away from the central star at incredible speeds. As that gas expands super fast into empty space, it cools down. You've probably felt this yourself, when you use a can of compressed air and the nozzle gets icy cold. It's the exact same principle, but on a cosmic scale so extreme that the temperature just plummets to almost absolute zero. So we've looked at all this incredible science. But our connection to these stars goes back way further than telescopes. Humans have been weaving stories about them for millennia. So let's shift gears and look at the myth behind the name, the powerful and tragic story of Chiron, the wise centaur. The story basically has 5 parts. It kicks off with a battle, but then disaster strikes. Chiron, who happens to be immortal, is accidentally hit by a poisoned arrow. Now, because he can't die, the poison doesn't kill him. It just condemns him to endless, agonizing pain. So he makes this incredible sacrifice. He agrees to give up his immortality to save the Titan Prometheus. And for this noble act, Zeus honors him by placing his image in the heavens forever. And that's really the heart of the story, isn't it? It's not about being the strongest or winning a fight. It's about sacrifice. Chiron's choice to embrace mortality, not just to end his own pain, but to do something selfless for someone else. That's what makes this such a powerful myth. Okay, so we've covered the science and the stories. Let's wrap up with some practical tips for any of you who want to go out and see these things for yourselves. Because really, there's nothing quite like seeing it with your own eyes. So here are a few things to try. First, find those 2 bright stars, Alpha and Beta Centauri. They're called the Southern Pointers for a reason. They point you straight to the famous Southern Cross. Second, grab a pair of binoculars and aim them at Omega Centauri. You won't see a single star. You'll see this fuzzy, glowing snowball. And for those of you with cameras, Centaurus A is an absolutely incredible target. You could actually photograph the dark dust lanes from that galactic collision. When you really think about it, Centaurus is a perfect synthesis of things. It's where hard physics, the rules that govern stars and galaxies, meets our very human need to find meaning and tell stories. You have this amazing scientific journey to our nearest neighbor, and at the same time, this ancient tale of noble sacrifice. It really makes you wonder, doesn't it? What does this incredible celestial supermarket really tell us about our own place, somewhere between the known and the unknown?
Thank you, friends. Strive for understanding and become wiser. See you soon.